The Black Hole Hunters project has almost 9,000 registered volunteers, plus countless anonymous volunteers as well. And we asked them to send in some of their favorite questions about black holes, some of the things that they're just dying to find out about. So we haven't got time to answer everything that they sent in, but they sent in lots of fantastic questions, and we're going to try and answer some of those for you now.
Do black holes look the same from different angles?
How a black hole appears would definitely look different depending on how you looked at it. Black holes have other properties like spin that can affect how matter moves around it. And because we can't actually see the black hole, we can only see its effects on its surroundings. If it does spin on an axis or something, that will certainly have an effect on what we see.
If a black hole is accreting material, then the disk that forms around it has a certain orientation. It actually has the orientation of the angular momentum of the material coming in. Very close to the black hole, it can be misaligned compared to the rest of the disk and start to move towards the equatorial axis of the black hole. Because yes, a black hole does have a spin axis, all black holes are spinning. So then what we see does depend upon the angle. You mentioned the Event Horizon Telescope images. The Event Horizon Telescope images were showing how light gets bent around the black hole. So actually it's really sensitive to where that light starts from. So it does really depend upon inclination. If we could access information for self-lensing black holes, such as the spin, so how rapidly rotating is your black hole, that is also a function of inclination. But we don't have a disk around self-lensing black holes, so it's a much more complicated prospect. So yeah, interesting question.
What is actually spinning if the center of a black hole is a singularity?
When you have a spinning black hole, as all black holes must spin, your singularity is no longer a point, it's a ring. They're called a ring singularity, the name is incredibly inventive. And they've been theorized to have something to do with wormholes. But I think it's important to point out that a singularity is just something that occurs in an equation. There's a singular solution. So you've got to be a little bit careful. People tend to believe that there is this dot, right? And then everything is in that dot. Well, maybe, but in reality, it's just telling us that our understanding of quantum gravity is incomplete, as it is enormously incomplete. So you've got to be careful about things like singularities. But certainly the mathematics tells us that the singular solution to our equations is not a dot. When you have a rotating black hole, it's a ring.
Do black holes accrete dark matter?
I guess first we should discuss what dark matter really is. I mean, there are some theories that postulate this might be just very, very tiny black holes or even very, very tiny neutron stars. So in that sense, yeah, it would be just like regular matter. I mean, what we know about dark matter is that it interacts gravitationally and it doesn't interact electromagnetically. So as long as whatever form of dark matter we come up with, yeah, it will behave like matter gravitationally.
There's no reason that dark matter, whatever form it takes, shouldn't respond to gravity. In fact, we know that dark matter has a gravitational influence. We can see that in rotation curves of galaxies. We can see that when we see lensing by galaxy clusters, because most of the matter in galaxy clusters is dark matter, and that is the thing that is bending the light. So yes, dark matter has a gravitational influence, so there's no reason to assume that dark matter would not be accreted onto a black hole.
When two black holes merge, what happens to that singularity? Do they both exist within the event horizon?
God, that's absolutely rock hard.
So when two black holes merge, what happens? Truth is, I can't tell you, because it's past the event horizon and all information at that point is lost. But the black holes do merge. My hypothesis would be perhaps they create one singularity.
And I guess one thing we should say also is that the singularity is really, we are not entirely sure whether it's something physical or it's a problem with our theory, right? Or theory or general relativity cannot really explain what's happening at the center of a black hole. So whether there's something to worry about could be called into question in the first place. I would think of it as two bodies merging, like two stars. Like in a normal star, there's nothing special about the center in a way. So I would tend to think of it in the same manner. Like it's just that we cannot see what's inside of this. There is this black envelope, right, or this region of space and time where we cannot see because photons don't get to us. But there might be nothing particularly special about the center of this system.
People are modeling what happens when you have black holes which merge together, how the space-time is affected, how what we call the sort of quadrupole component, the energy of that quadrupole gets converted into gravitational radiation which propagates outwards. So the actual point where you have what you call sort of ring down and the point of merging is where those singularities in principle meet together to become one larger black hole. Of course, those two things have to move together, and the event horizon is a certain distance away from the singularity. So in principle, you have one singularity moving within the other, but in reality, you've got the mergence of two spacetimes, which is a much more complicated mathematical problem. Okay, so yeah, I think the answer is it's complicated, but let's trust mathematicians to have done it right. There's some very cool, gnarly videos out there showing these two things sort of merging together, so, you know, check that out instead.
If you had a black hole with the mass of the whole known universe, how big would that black hole be?
So working out the size of a black hole is difficult because it doesn't have a distinguishable surface. It's not like a star where we can work out where the edge is. Instead, what we do is we define something called the event horizon. This is the point at which no light can get out, and we say that's how big the black hole is.
So all you would have to do is take all the mass of the universe and work out what would be the event horizon of a black hole of this mass. Now, what is that amount of mass, and what number does that calculation lead to? I do not know.
Would a black hole lose mass if it accreted antimatter?
So if a black hole was to accrete antimatter, all that would happen is that matter would eventually, once it crosses the event horizon, it's contributing to the space-time, it is present within the event horizon. So whether or not it by some means would combine with matter to produce energy, that energy can't escape anyway. And the equivalence of energy and matter is such that you're still just adding mass effectively onto a black hole. In the same way that if you were to accrete radiation or photons onto a black hole, that is also changing the mass and also the angular momentum of it. So luckily E equals mc squared means that it's not going to have much of an impact, it's not going to lose mass.
So if a black hole accreted antimatter, I don't personally think it would lose any mass. The reason being is when we talk about accretion, we talk about the conversion of mass to energy. For all intents and purposes, when antimatter is converted to energy, that's indistinguishable from matter being converted into energy. So as long as we can assume that exactly the same quantity of energy was released, then I would say no.
If you want to join the Black Hole Hunters project, then click the link in the description below and you can join a community and potentially help make a huge scientific discovery.